The cycles, we've got the water cycle over here, and I've got the carbon cycle. The water cycle is, we learned it in like 5th grade. We have evaporation, and then you have condensations, where it actually forms the clouds up here. It condenses back together. It's like if you have a glass of water or an iced tea in the summertime, and you get that condensation on the outside of the glass. That's because you cool down the air on the outside. It's not, the water didn't go through the glass to the outside. That's actually water vapor that was in the air touching that cold glass, and it forms water droplets on the glass itself. Maybe you've taken a hot shower and you've noticed the mirror fogs up. That's because of that moisture that's in the air touches that cool mirror, and it condenses back into liquid form. So these clouds up here, they are little bitty liquid droplets. It's not of gas. It's like if you go to Busch Gardens, they have the mister when you walk through Italy when it's very hot outside, and the very fine mist of water droplets. It's liquid water. It's not a gas, but it's so fine that it can't fall to the ground because that rising air holds it aloft. And then when those little droplets bang into each other, they get a little bit bigger until they get big enough where that rising air is not enough force to keep it up there, and it falls back to the ground. And so that's why you get precipitation from, which is the next part of the water cycle. The more uplift, or the more you have air rising up, the bigger the drops have to become before they can overcome that uplift and fall back down toward the ground. That's why thunderstorms particularly have very large raindrops. There's a lot of instability in the air and a lot of uplift, and so those drops have to get really big, bouncing into each other and getting bigger and bigger and bigger until they can fall back to the ground. Whereas in the wintertime, you might have a light drizzly rain where there's not a lot of uplift in the atmosphere, and the raindrops don't have to get that big. So once the water falls back to the ground, a lot of times you've seen it as runoff back to the ocean. All water does want to return to the ocean. But you can also have another one called infiltration or percolation. That's where it gets into the groundwater. You'll learn about this next year in Earth Science. That too, in the ground, does flow back towards the ocean, but very slowly, very slowly. There's one more thing as well, other than evaporation, is plants. Plants can pull the water out of the ground, and whenever it's doing photosynthesis, releases some of that water vapor back to the air, and that's a process known as transpiration. The second part of this, we have the carbon cycle, and that's where, with photosynthesis, basically plants take in CO2, and what they're interested in is that carbon part of the CO2, because it's trying to form this thing called a carbohydrate. All right, C6H12. I'm trying to write with the mouse, so it's a little bit sloppy here. O6. Okay, that's a simple carbohydrate right there. It needs that carbon from carbon dioxide to form a carbohydrate. And then, because it only needs it doesn't need this oxygen, the H12O6, it gets that from the groundwater, that H2O that it pulls out of the ground. And so it grabs both of those. It doesn't want the oxygen part of carbon dioxide, so it throws it back out into the atmosphere. So when they do photosynthesis, plants release O2. And so this carbon and this water down here, it makes a very special molecule that can store energy, and that's, of course, is called a carbohydrate. All right. If the plant stores it, it's stored energy. Something can come along and eat the plant, and then they'll eat those carbohydrates. A carbohydrate is just a sugar, glucose. And if you eat too many carbohydrates and don't use that energy, of course, you will store it as belly fat. All right, so that's the first part of it. When you're an animal and you've got now some of that carbohydrates and you want to release that energy, well, you breathe in the O2. And when you break apart that carbohydrate that we have up there, you're doing the reverse of it. You're getting the energy out of it, but then you've ripped apart the carbon from the from the water that you have up here, and so it takes that oxygen that you breathed in and recombines it with the carbon, and then you breathe out CO2. You also breathe out water vapor, and you'll notice the more you exercise, the more energy that you use, the more you're breathing. You breathe heavier, you go jogging, because you got to get rid of that carbon. You breathe in the oxygen, and then you combine it with the carbon, and then you breathe out the carbon dioxide. And then the process just repeats itself. This is known as the carbon cycle.